Are we ready? Would you mind closing that door? I have a thing with crowd noise, so we're going to try and close the doors here. I am absolutely thrilled to have such a large audience today. Thank you all so very much for being here. This is awesome. So anyway, you've read the description, hopefully, and you know what this is about. And I teach at a community college. I teach biology. So this is kind of outside my field of trained expertise, but I've been a hobbyist most of my life. And what got me into ham radio was experimentation. I was playing around with electronics, and somebody said, hey, if you toggle this pin on and off at this frequency, it'll make a square RF wave. And you put that through a low-pass filter, and baby, you got a stew going, right? So after that, I said, man, I need to get my ham radio license and learn about this stuff. And here we are many years later. And today I want to talk to you about a Raspberry Pi-based educational project that I've been kind of pursuing for the past several years. STEM, for those of you that don't know, stands for Science, Technology, Engineering, and Mathematics. And these are fields that we're really trying to get youngsters into because it's not something that a lot of young people are super enthusiastic about anymore. And hopefully we can change that, right? And we'll throw some arts in there too, right? For good measure. I studied music a lot as a kid, and it really did help, I think, in my understanding of some of this technical stuff. So these are some of the different incarnations of this project, and there's a few that I have up front here that are small and portable enough to be brought in. And basically the way the project works is you take your inexpensive handheld. I've got a Bofang UV5R here set to the receive frequencies on these devices. And I've got it set up to where we hold down the push to talk button and we press one of the DTMF buttons, and whoop, it's kind of jittering. Well, that's what you want to see. It was working just fine, wasn't it? And now it's jittering. Maybe, huh? Am I too far away from it, or am I just, man, that's unfortunate. Let's try the other one, shall we? Maybe, yeah, it's Murphy's Law. Hey, the other one's working. Yeah, this little one is actually the more impressive of the two anyway, I think, because of how inexpensive it is. The motors that are driving this thing around, I was talking about them briefly before the talk here. I got them downstairs from Lee. Y'all all know who Lee is, right? He's at every Hamfest. He's always got the most interesting and varied collection of toys down there, and he was selling the motors for $4 a piece, and I didn't know what they came out of, and some of you already know because I've told you, but anybody want to guess what they came out of? Pez dispenser, screwdriver. Any other guesses? I was kind of not, I was surprised. ATM machines. They came out of ATM machines.
It's a gear motor.
Yeah, it's a DC gear motor. No idea what the gear ratio is on it. I can tell you that it draws so little current that I'm able to power it off of a very inexpensive motor driver board that really is rated only to handle about 1.2 amps at this voltage peak. So very little power draw on these things. I don't know why that other one didn't work, and that's the one that usually works better too. I've got it set up to run on 70 centimeter simplex, and it is just flat not responding to my commands now, which is strange. We've run this thing. We ran this one at STEM Mania for hours and hours and hours on end, and it didn't have any problems, so it would be the one to embarrass me now. I do apologize. Reboot it, right? I may do that here in a little bit. Yeah, give it a good kick. Now that is the one I did just reconfigure right before the presentation, set it to a different frequency. So I'm going to blame it on that. The other one worked, so I saved some face. Anyway, I did want to talk to you a little bit about, hey, this is working. STEM Mania. This is an event that we put on at my college, Weatherford College, Wise County. Every year we've put it on since 2013, and science, technology, engineering, and math, ham radio immediately comes to my mind, right? It involves all four of those things and more. And here's some of the different activities. This is a photo taken by our club, the Montague County Amateur Radio Club, from 2 or 3 years ago, back whenever we had weather that allowed us to do this outside. There's Susan, K5YNC, out there teaching kids about CW probably. And you can see they're fairly interested. They like to know what this is all about. I did want to take a moment to recognize a lot of the people in the audience who were involved in helping us to make this a success. We had Alan and Cheryl Walraven, N5MSE, K5TTP. We had Dr. Gary Sullivan, no call sign, but we're going to get him licensed here sometime, peer pressure. Steve Smith and his wife were also there and were involved, but they couldn't make it to this presentation because they had some pesky emergency communications thing they had to go to instead, right? Robert Perkins, AF5IJ. We never talk on the radio, Robert. We had more ham radio operators at this year's STEM Mania than we have had ever, and there were several others at STEM Mania who just aren't here right now, and we had, I can't remember, over 100 different presentations and activities, and they're all geared towards fourth graders within the confines of Wise County. So ham radio was really just a small part of it, but it was very well represented, and this was one of the activities we did. Whenever I first started out with the idea of a ham radio controlled vehicle, it was considerably more complicated, and we did actually implement this 3 years ago at STEM Mania, and it involved a joystick from a Nintendo Wii and a parallax propeller microcontroller, a Bofang radio as a transmitter, another one as a receiver, another parallax propeller to demodulate the encoded signals, and then finally a motor controller to drive the vehicle around. And we were using a much bigger vehicle. It was this one. This is a modified Power Wheels car, so this thing is huge. And I gave a presentation over that 3 years ago maybe here at Cowtown. I think I had maybe 6 people in the audience, and it wasn't well received. And one of the things, I had a guy in the front row who was just super interested in trying to do something like this to get kids interested in ham radio. And one of the things that he said was a deal breaker is, it's too big, it's too expensive, it's too complicated. And I thought, okay, message received. So I took the original concept, which that's how complicated it was. It did involve a pretty fair deal of soldering and splicing and big bulky stuff you got to carry around with a strap over your shoulder, and a big bulky shoebox size thing you got to mount inside of a vehicle. And this motor controller can handle like almost 1,000 watts of DC power on one motor channel, so multiply that by 2 for 2 motor channels, and it was just too expensive. The motor controller alone in this particular implementation is like $130. So not something that you're just going to put together for a couple of fourth graders to destroy, although they didn't destroy it, so that's good. So the new concept is much simpler. We've got one handheld transmitter that sends a signal, and then on the other end we don't even have a transceiver. We're using a cheap RTL-SDR dongle, a cheap Raspberry Pi to perform the demodulations and to generate the control signals that eventually drive your vehicle around. So a lot less complexity, and you could probably build this, truth be told, with 0 soldering if you got creative with things. I think I did some soldering because I'm not necessarily that creative. So I had pitched this concept as a possible kind of future goal. Raspberry Pis can be had for $35. Lee, I'm advertising a lot for Lee lately, has Raspberry Pi 2s down there. He's got a bunch of, probably 100 of them, for $10 a piece. They don't have Wi-Fi, but you don't need Wi-Fi for this project. So if you've got some of those or you want to get some of those, you can save a little bit of money by using a slightly older Raspberry Pi. The RTL-SDR dongle, is everybody familiar with those? Some of you aren't, some of you are. This is kind of, I've seen this as a topic of discussion on a lot of Hamfest presentations. It started out as a Chinese digital TV tuner that you plug into your computer and hook an antenna up to it and you can watch TV on your computer. And it turns out a bunch of people found out whenever they cracked it open and looked at the chip on the inside, it's really just a broadband radio receiver, right? It's really just dumping quadrature samples into a software-based buffer. And they very quickly started developing drivers for it that worked in Windows and Linux, and from that point it can be used as a fairly decent, especially for the price, software-defined radio receiver. So you can get them. I think the cheapest I've seen them is probably about $9 or $10 on Amazon. You can get them for more than that too. You know, ham radio, you can pay as much as you want for something, right?
I've seen those dongles that some guys have hacked it in to where you can pick up the smart meters.
Oh man, that's interesting. See me after. I want to know about that. I want to know what those things are saying. Motor controllers, the things that actually take digital signals and feed power into motors, the prices on those vary too. The one I'm using on the little one that didn't drive around is the same one I was using to drive the Power Wheels car around. That's the $130 unit. So, you know, you can spend triple digits on those if you want to. The one I was using on the small, ugly one that did work just now, single digit. You can buy those for $3 or $4 probably, or less, depending on how many you want to buy at a time. So my goal was to use all of this in place of that costly and complex system I had before. And the way it works is you hold down the push to talk on your radio, you hit the 2 button and it drives forward. You hit the 8 button, it drives backwards. You hit the 4 button and it basically rotates counterclockwise, and you hit the 6 button, it rotates clockwise. All the other buttons, the 3, 5, 7, 9, and then all the others, you could assign some special purpose. You want to put bells and whistles and flashing lights on something like this, or a little robotic arm with a gripper, you've got plenty of other ways to control those mechanisms that aren't tied up in driving this thing around. And I thought about doing that, and I just, you know, too many irons in the fire, I guess you could say. But it's always up there as an idea. As far as Part 97 is concerned, there's 3 kind of special things that we have to, 3 special rules we have to follow as ham radio operators when it comes to radio control vehicles. It says the station identification procedure is not required for transmissions that are directed only to the model craft, provided that a label indicating the station call sign and the station licensee's name and address is affixed to the transmitter. So when you saw me holding my transmitter, I've just got a little laminated tag hanging off of it with that information. I intended to have the sign man make me up some really, you know, keychain tag or something, but I'm given to understand he couldn't make it here today, so that'll work for now. It also, radio control's kind of neat. It lets you break some rules, right? You mean I don't have to ID my station like we do on every other transmission we make? It also says that control signals are not considered codes or ciphers that are intended to obscure the meaning of the communication. So the data that you're sending to control your vehicle could literally be anything, and anybody who's listening into it doesn't have to have the foggiest clue of what it means, because it's not intended for a human recipient. It's intended for a machine recipient. In this case, they're DTMF codes, and I have already told you what they mean on the previous slide, so it's obvious I'm not trying to hide anything from you. And then another stipulation is transmitter power must not exceed 1 watt. So if you're going to use your UV5R, you got to put it on low power. And make sure that you're not using one of the jacked up models that they amped up the transmit output power. I've got one here I bought at Main Trading Company several years back. It's a UV5R MHP, and I put a little stubby antenna on it because I just like the smallness of it. But this thing puts out more than 1 watt on low, so I don't use it for radio control. But even then, it's not much more than 1 watt. And then as far as considered operation goes, ideally, if you're doing radio control, you would want to do it on 6 meters. Channels specifically designated for radio control, but I went down there and looked, and I didn't see any 6 meter handhelds. Did anybody see a 6 meter handheld for sale in the flea market?
The early Yaesus, the little BX5
Yeah.
were 3 band.
Oh, okay. And 6 meters was one of those bands? So I'd love to get my hands on a 6 meter handheld that doesn't break the bank, but I haven't seen any. So most of your cheap and readily available radios are either 2 meter, 70 centimeter, or both. And most of your band plans are going to have simplex or experimental kind of frequency allocation. So I'm using just FM simplex frequencies for controlling these. And since we're in North Central Texas, I'm using the Texas VHF FM Society band plans, which were, I think these were drawn up in the 90s, but we still abide by them for the most part. So there's a link there. And they're pretty useful. I try and check to make sure the frequencies aren't in use. Before we got started, I kind of gave a call out with my call sign to make sure there wasn't somebody using it, and I got nothing back. And I say, although station identification by voice is not required, it's not forbidden either. So you can always say, hey, this has been a radio control test by K5DXD. Thanks for tolerating my existence, you know. And then I'd mentioned you want to make sure that you're using the right radio, and make sure if you're going to be doing a lot of driving around, you might try and set your transmit overtime timer to the maximum, which is 10 minutes on one of these UV5Rs. I've played around with it, and sometimes the CTCSS and DCS kind of mess with the DTMF decoding a little tiny bit. Maybe it's because of the way I wrote the software though, so who knows. So I turn it off. Anyway, here's an RTL-SDR dongle, and this is one of the more expensive ones. I'm assuming the metal case actually provides some RF shielding, but I haven't tested it. Anybody think that it does? Maybe. I think I paid $20, $25 for that one, $10 and up. They've got different chips in them, but they all pretty well function the same as far as I can tell. I have a few different ones that I play with, and it's not just useful for this project. You can actually use it as a radio receiver, and there's different types of software that have varying degrees of functionality. You can get waterfall displays that cover a slice of the VHF and UHF band of interest. They can go down into some of the higher HF bands, although the reception is usually pretty crummy. I one time hooked up a chain of various filters and amplifiers to try and receive some HF and came up with a little bit of success with it, but generally speaking, it's not worth the effort to do that. But it's fun to play with. I put some information in here about Raspberry Pis. It's outdated now. Since I made this slide last year, they've come out with 3 new Raspberry Pis. The Raspberry Pi 4 has 3 different incarnations that I think the only difference is how much RAM they've got. I haven't really played with the 4s yet. I still mainly stick to 3B Plus and Pi Zeros for what I do. I'm using Pi Zeros in this project, and I'm using the wireless versions just because I like to be able to connect to them by Wi-Fi and go in there and troubleshoot, reconfigure them, and that may be what got me into trouble is I went in and reconfigured it before the talk. Half a gig of RAM, fairly low power draw, really small. $15 at Micro Center for the one with Wi-Fi. I think Micro Center is still selling the non-wireless version for $5. Gary, has that been your experience? Okay. It's like, well, I really want the Wi-Fi though, right? So anyway, that's just kind of a slide I threw in here. I put this presentation online, and I'll provide you with a link so that you can download it in the event that you want to. I put way more slides in here than I should have. I promised myself I wasn't going to subject you to death by PowerPoint, and I'm doing it anyway, so I just put that in for reference purposes. And I also put this in for reference purposes. It's got a 40-pin header, and those 40 pins have general purpose input output pins on them, and then some of those can be assigned special purposes like running I2C interfaces and SPI interfaces, running old school serial interfaces and PCM audio interfaces and things like that, but they can be reconfigured as basically just make this pin an input, make this pin an output, make this pin a pulse width modulating output, things like that. The motor controller, the device that takes the signal from the GPIO and applies power to the motors to make them turn, that I'm using is a dual L9110 motor driver board, and I got mine from Radio Shack back whenever we had the mass extinction of Radio Shacks some years back in the DFW Metroplex. I picked up a dozen or two of these things. I didn't even know what they were. I just saw it had pins on it, and it had these, I thought it was just converting pins into the wire screw connectors. It wasn't until I got them home and flipped them around that I saw it had some integrated circuits on it that I realized it was something more than just a physical adapter, because I was getting these things for 10 or 20 cents a piece. Sure, I don't care what it is at that price, I'll take them. It turns out each one of these chips is essentially a transistorized H-bridge. So there's essentially 4 transistors in there that allow you to switch power in both directions through the motor. So it allows you to make the motor turn in one direction or the other. And with 2 of them, you can control 2 motors that way. The circuit itself is rated for somewhere between 3 and 12 volts. Somewhere under 600 milliamps of continuous power, and peaks around 1.5 to 2 amps. I thought it was less, but still not a whole lot of power in the grand scheme of things. Operating temperature 0 to 80 Celsius, and its inputs are logic level, but apparently it's tolerant of both 3.3 volts and 5 volts, allegedly. I don't mess with Arduinos enough to have tested this, but it does work with a Raspberry Pi, which is a 3.3 volt system. So I can tell you that does in fact work. And there's the Radio Shack brand right there on it. The software that makes this thing work, that actually takes the audio signal from that FM radio transmission and uses it to control the vehicle, I wrote it in Python, and basically it manages the acquisition and analysis of that signal. It starts up a command line based FM receiver called RTL-FM, and then it takes the audio output from that, which is really just a stream of bytes, and then it pipes it into a decoder that I've written that determines which DTMF tones are present. And this library provides a class-based interface that allows you to determine which DTMF button is being pressed, whether it's being pressed, held, or released. And it also stores and recognizes sequences of DTMF tones. I kind of had in the back of my mind, well, what if obviously you want to be able to read DTMF tones in real time to drive this thing around, but what if you want to do something completely different with it, like remote-based control on a homebrew repeater? So I was thinking it would be really nice if I also built the functionality into this to remember a sequence of tones and compare it to something and take some action based on that. So it has the capability of doing that too. And I've got it in a GitHub repository. There's the URL for it, and I'll have it again at the end of the presentation in the event that you want to look it up. And this presentation is also in PDF form in that GitHub repository. And I also put a number of demo scripts that import this library and use it in various ways, you know, printing the information out in the shell so that you can see it. Just out of curiosity, how many people would consider themselves proficient in Python? One. Gary, you don't consider yourself proficient? Oh, okay. All right. Okay. Well, you don't necessarily have to be proficient in Python to use this library I've written. If you were to take one of these demo scripts that I've written and take out the license and take out all the comments and take out some of the more anal retentive error checking that I've done in them, you might have 10 lines of code that allow you to take that radio signal and print out which DTMF code is being pressed. So I tried to make this interface as simple and as usable as possible based on the best programming practices that I know at the time. So there are some dependencies if you want to use this software. You got to have Python 3 running on your system. Most of your Raspberry Pis come with Python 3, so no problem there. If you're using it on some other system, you may need to install Python 3. There is a Python library called NumPy, and this is mathematical. It's a library of mathematical subroutines and functions, and that's where the magic really happens. I wish I could say that the way I made this program work is I'm just super good at math, but it turns out the way I made this program work is NumPy is super good at math, and I'm taking advantage of that. It does the heavy lifting for me. It performs a mathematical operation called the fast Fourier transform. Anybody ever heard of that? We had a test session at our club the last week, and we had 2 people pass, and they were both mathematicians, and I thought for sure that they were going to be in the audience and they were going to criticize my description of how the fast Fourier transform worked, because I'm not a mathematician, so my description is going to be a very simplistic description based on how a biologist understands it to work. But anyway, more on that in a minute. If you don't have it installed, there's the command line argument to install it. And then the other thing you need is the RTL-FM receiver. And it's included in the RTL-SDR package for Linux. So you can get it by just saying install RTL-SDR. And that's pretty easy on a Raspberry Pi. There's one issue I ran into. I took an SDR dongle and plugged it into this computer here and said, let's just see if my script will run on this without me doing anything. And the problem I ran into was it said, no, RTL-FM won't run without administrator privileges. And I wasn't trying to run it as the administrator of the system. I ran it as the administrator and it worked. But you shouldn't have to do that, right? That's not really the best practice. So there is a fix at somebody else's GitHub page. It's basically just a sequence of steps you follow to change the permissions that are required to run that FM receiver, and then it runs. So I put that in there because it's kind of a conundrum until you find it, and then it's pretty easy to fix. So how does DTMF work? What is a DTMF code? Well, you've got 16 buttons on your keypad that can produce a DTMF tone, and each one of them is essentially producing a combination of 2 tones. So when I press the 1 button on my keypad, it's putting out a combination of 697 hertz and 1209 hertz. So that's why they call it DTMF. Dual tone, meaning 2 tones are being produced, and multi-frequency because they're using 8 different frequencies arranged in a 4x4 grid to give you 16 possible combinations. And they've arranged them so that the 4 lowest ones make up the rows and the 4 highest ones make up the columns, because it's easier to discriminate them that way, which is kind of, they were thinking ahead. So what is the fast Fourier transform? As I had mentioned, it's an algorithm. It's a sequence of mathematical steps that converts a complex waveform into a series of coefficients or numbers that represent the relative intensity of each pure sine wave that makes up that complex waveform. The fast Fourier transform is an optimized version of the discrete Fourier transform, which is based on the concept of Fourier analysis, developed by Jean-Baptiste Joseph Fourier, who was actually studying the propagation of heat. Fourier was one of Napoleon's chief scientific advisors. Just to put it into a little bit of historical context for you, this is kind of a mathematical representation of how the discrete Fourier transform works. If we have any mathematicians in the audience, then you'll understand what that means. Otherwise, it's just kind of pretty looking art. So, did that answer your question of what the FFT is? Probably not. So what is the FFT? The way I look at it is it takes a signal from the time domain and converts it into the frequency domain. It takes an oscilloscope tracing and it turns it into a spectrum analyzer tracing, right? That's the simple way of looking at it. So as the audio signal is coming in from that FM receiver, the software is taking it, picking it apart, and saying, okay, I'm detecting a peak in this signal at 697 hertz and another peak in this signal at 1209 hertz, and then it looks up in a table and says those two tones correspond to button number 1 on the DTMF keypad. And then from there it says, does button number 1 do anything? And if it does, then it does that. So fast Fourier transform is used pretty routinely in digital signal processing. So we had this out at STEM Mania, and I had one of my former students who went and got his ham radio license based on his experiments with our rovers, and he was the control operator, and he was letting the fourth graders drive this around as I guess you could say third-party traffic providers at the event. And it was indoors because the weather was kind of crummy. It was rainy. Alan, you remember the weather was kind of crummy that day, so we were all indoors. We had 800 some odd fourth graders in a single giant acoustically resonant building, and this thing's out in the hall, and I've got one poor 19-year-old, 20-year-old student out there helping these students play with it and explaining to them how it works. And when I initially designed this particular one, I cut this piece of plywood out by setting a square kitty litter bucket on top of it. And my goal was eventually I was going to spray paint the kitty litter bucket and build a robot inside of it, and I was going to call it the Bucket Bot. And so that's what we'd been calling this thing, the Bucket Bot. And the fourth grader must have misheard him, because they went home and wrote letters back to us telling us about what they enjoyed about STEM Mania. And Gavin from, I think, Boyd said, another activity I liked was the HamRover. Although I didn't get to drive it very long, I still thought it was cool that the remote was a walkie-talkie and that the guy that built it by himself, and its name was Bucket Bob. So Cheryl, to answer your question from before the presentation, yeah, they do have names, and this one was changed by a fourth grader, and now Bucket Bob has stuck. So that's what he's called, and Bucket Bob was misbehaving earlier. Those of you that were here beforehand saw him working perfectly fine. But anyway, questions? This is an early picture from when we were still messing around with the Power Wheels and driving it around with a Nintendo controller. And this is one of our former cats who has since passed away, Kitty Rowans. And the joke was always, we're out there talking about ham radio, and Rowans hears us talking about ham and says, I can has ham. So I thought I would put that up there for questions. So here's the URL where you can find this if you're interested in it. One of my goals here, and I see we've got a youngster or so in the audience, was to try and give you enough information that if you wanted to start hacking together something like this to play with, there's really no cheaper way to build a cool radio control project for a young ham radio licensee than this. This little cheap one that I put together, the reason it looks so crummy is because I threw it together over the course of a weekend to demonstrate that it can, in fact, be thrown together over the course of a weekend and work. It's a caster wheel from Harbor Freight. It's a couple of motors I got from Lee last year at Cowtown. It's a couple of mismatched antenna mounting brackets that I couldn't even find a matching pair of. The spacers, anybody know what those spacers are? I ran out of 1/4-inch washers, so I had to get creative here, y'all. They're 9mm shell casings. I drilled out the primer pockets and made spacers out of those. Yeah, it's all just kind of zip tied in place. I'm using a 3D printed 18650 battery holder here. You can actually buy 18650 battery holders down in the lobby if you don't have a 3D printer. 18650 battery, they have them down in the lobby brand new, or if you're like me, I harvested these out of a quote-unquote dead laptop battery. Usually it's just one cell in there that doesn't want to cooperate, and the other 15 or 16 are perfectly fine. They can be recharged and used several hundred more times. Nominal voltage on them, somewhere around, I think they 3.7 to 4.2 volts. So at full charge, this thing's putting out over 12 volts, which is okay. I branched that off. Half of it goes into the motor driver board so that it can be fed to the motors. The other half is feeding into a cigarette lighter adapter that converts it down to a USB, and that feeds into power the Raspberry Pi. So very few parts are needed to do this, and it would make a nice father-son or father-daughter or mother-son or mother-daughter project. Make a nice Boy Scouts or Girl Scouts project, I think, I hope, anyway. One of my goals is to try and not have our hobby die whenever all the old timers go silent key. So anyway, if you don't have any more questions for me, then I will just set this up here, and if you want to come and take some photographs of it or what have you, then you can. How are we doing on time? Oh, we're doing pretty good on time then, right? All right, well, thank you very much for being such an attentive audience. I appreciate you being here.